Hello, everyone, and welcome to the HackFS Consensus Lab workshop introducing Interplanetary Consensus IPC. Joining us today is Alfonso de la Rocha, who will be taking us through this session. And with that, I'll pass it over to Alfonso to get the session started.
Thank you much, Rocha. Thank you for having me here. So today, hopefully I will do a high-level overview of IPC so that you get a sense of what is this framework, how you can use it. And finally, I will do a quick demo where I will deploy a smart contract in one subnet, a subnet that I have running. But in any case, I will point to all of the instructions and the getting started guides, docs, and so on, so that you can tinker with it your own. Okay, so I don't know if we all agree, but I guess that everyone is aware of how consensus algorithms in blockchains are a bottleneck. So if we want massive adoption in Web3, being blockchain one of the key models of Web3, we really need to scale the consensus algorithm of our blockchain networks. And if we see at what the two most used networks, which are Bitcoin and Ethereum, there we see that the throughput is around the dozen of transactions per second. And in order to scale them, different layer 2 solutions are coming into these ecosystems. But if we look at more like next generation, if we can call it like that, blockchain technologies, we see that all of the technologies that try to scale vertically, they are limited by the validator spec. So in the end, we are the consensus algorithm, we are limited, the throughput is limited by the specifications of the validators that are running that consensus. So we see that we can have a whatever transaction hope, but in the end, like the sequentializing stage of the consensus is limiting the amount of throughput that we can get in our blockchain networks. After these realizations with IPC, what we are trying to do is to horizontally scale blockchains. So seeing that we have this limit of vertical scaling, where there's a maximum transaction throughput that we can get at a consensus layer, with IPC, what we want to propose is a framework that allows us to horizontally scale the same way that we horizontally scale right now in cloud infrastructure. And these are the kind of targets, like when we were designing IPC and like as we are deploying and we are developing IPC, these are the kind of targets and the kind of features that we are targeting as goals. First of all, like as I've said, if we really want massive adoption of Web3, we should be able to tackle and to adopt with our substrate, with our infrastructure, Web2 scale throughput. And this is not the case right now. I mean, there are some attempts to deploy social networks, to deploy other high throughput applications, but so far, the moment we go through the blockchain, we have a scalability limit there. But then there are other interesting features that currently we don't see in blockchains and that by horizontally scaling we could achieve, like for instance, secure global finality, fast optimistic local finality, which means that depending on our use case, we may want really fast local finality and like then slower and more secure finality in other levels according to the use case. And right now we don't have a way of fine-tuning the substrate and fine-tuning the consensus and the finality of our blockchain network in order to fit the needs of our application. Blockchains generally, they are not partition tolerant. So if we are running a use case on a blockchain and part of our network or the network where we are interacting with loses connections with the rest of the network, so there's a partition in the blockchain network, there's no way to make progress, make the use case, like our application, to run and potentially like catch up in the future. So the idea is that with IPC, we're going to build subnets that will be partition tolerant. So we're building an isolated instance of a network where we can run our application and we will be able to interact with the rest of the networks in this ecosystem. Meaning that even if for some reason, our network is running locally and loses connection to the rest of the hierarchy, we would still be able to operate locally and eventually settle our changes to the rest of the network. And finally, like what I was mentioning, it would be great if we can have horizontal scalability the same way that we have it in cloud infrastructure these days. And it would be great if this can be demand-based. So instead of like the protocol enforcing, like in sharding or any other horizontal scaling proposals out there where partitioning is explicit and like the storage is partitioned explicitly, it would be great if users could play with the substrate, play with the infrastructure to fine-tune it to their needs. And this is basically what we're aiming with IPC. So in IPC, in the end, what we have is an on-demand horizontal scalability framework in order to horizontally scale initially Filecoin. So obviously we are focusing on Filecoin initially, but like the design is general enough to allow us in the future to port this solution to other networks. And how IPC works is in the following way. Like we start from the Filecoin mainnet, and whenever a user sees that for some reason, like for instance, in Filecoin, we have 30-second block times, and for their use case, this is not good enough, they will be able to deploy a new subnet, so deploy a new network instance that has still, by design connectivity, so by design interoperability, so the ability to interact with the Filecoin mainnet from this isolated network that it spawns, and it will also anchor its security to that of the upper layers of the hierarchy. So in this way, whenever a user needs, and I'm going to show a figure in a minute to illustrate this, but whenever a user deploys a new instantiation of a network, it will, in a new layer, it will still be able to interact with the rest of the network and anchor its security to upper layers of the hierarchy that potentially will be more secure than the subnet. And right now, these subnets, they run a BFT consensus. So it's a BFT-based consensus, kind of a BFT with weighted consensus where there's like the voting power is weighted by the stake and the collateral that a validator has in a subnet. And another interesting property that these subnets have is that they enforce, so IPC enforces a firewall property, which means that whatever happens in a subnet, so if something wrong goes in a subnet because there's an attack, because there's a misconfiguration or whatever, the impact that this has over the upper layers and the rest of the networks in the hierarchy, it is limited. And as I said, like initially the subnets, they all run a single consensus that is a BFT-like consensus, but in the future, we're trying to make this as modular as configurable as possible to enable other kind of consensus algorithms. And how is this implemented? Like in the end, all of the operations and the logic of IPC are implemented through a set of on-chain FVM contracts in each of these networks that we run. So in the Filecoin mainnet, and from there to in the different subnets. So to illustrate a bit how IPC works, let's imagine that here in the root, this is our Filecoin mainnet. We have a 30-second block times. We deploy our super cool DeFi application, and it doesn't have the kind of like finality or the features that we need. Users will be able, from the Filecoin mainnet with IPC, to deploy their own subnets in this way. So they will be able to spawn in a new level, and each of these subnets, they are independent networks in itself, and they are all running, so validating transactions in parallel. Subnet will be running this BFT-like consensus. They each will have their own state, and they will be able to run independently, with the caveat that through IPC, each of these networks, they will still be able to interact with other subnets in the hierarchy. So root T01 will be able to interact with root T02. And also, we have a periodic checkpointing from subnets to the upper layers of the hierarchy, so that we can keep some pieces of the state of the subnet in the upper layers in case something goes wrong, so that we can build fraud proofs, or we can build any other kind of security enforcement protocol. So the idea is that we, right now, the UX, as you'll see in a moment, it's a bit rough, but the idea is that we want to expose all of these interfaces to the users so that they can fine-tune the substrate to their own needs. And this is recursive, so meaning that the same way that from Filecoin mainnet, a set of users were able to deploy their own subnet and start operating over there and interacting with the rest of the hierarchy, if at some point we see that there's a subnet, that it's reaching capacity, or it doesn't have the kind of substrate of features that we need, they can also deploy a new level of subnets from a child subnet. So we could have layer 3 and so on. And in this way, IPC builds a hierarchy, recursive hierarchy of different subnets that interact with each other and like run the protocols, run the IPC protocol throughout all the hierarchy. And going back, moving into like more of the implementation of the protocol, how does this look like from a system perspective? So let's imagine that we have this rootnet and these two child subnets. What we have is a set of on-chain contracts specifically and mainly the gateway actor and the subnet actor. The gateway actor is the main, like the common actor that all subnets have and that implement the core logic of IPC. And then the subnet actor, which is a user-defined actor that subnet operators can deploy in order, like with the specification of all of the policy for their subnet. So the collateral, the kind of requirements in order to join as a validator in the subnet. So all the policies that you can think of and that you want to implement in your subnet. This subnet actor, right now we have a reference implementation, but in the future, like we are looking into all users to come up with their own subnet actors, deploy their own subnet actors, and in this way have an ecosystem of subnet operators and subnet developers. So we have these actors that are all around like in the different subnets and that implement the on-chain logic for the protocol. And then we have the IPC agent, which in the end, like we can think of this as an orchestrator, so a process that we run locally in order to interact. So it abstracts from all of the interactions that need to be done for IPC with the different networks. And finally, we have the last piece of the puzzle, which is the peer implementation for these subnets. So in the end, we have like these subnets, what they're running is the same exact, at this point, it's running the same exact stack as the Filecoin network, because what we have like subnets, they run a fork of Lotus that we call Eutico that has been modified to run a different consensus algorithm. And this consensus algorithm is the high throughput VFT protocol that I've been talking about. That is, sorry, that it's called the Mir Trantor consensus algorithm. So yeah, and the IPC agent in the end, like it's your entry point for IPC. So in the end, like if you want to run an application that interacts with Filecoin mainnet for some storage stuff, then you have some application in a layer 2 subnet and then a layer 3 subnet. And you want your application to be able to interact with all of these subnets. Usually you don't interact with each of these subnets individually, especially when you want to do IPC specific features, but you use the IPC agent, which is the same instance and interacts with all of these networks. And it abstracts for you all of the low level interactions that need to be done IPC wise in order for your application to be able to use IPC. And finally, like to wrap up this high level overview, okay, IPC is really cool, but I don't know when to use it. Here I share a few questions that you can ask yourself to see if IPC fits your use case or not. Like you can think of IPC as a, let's call it cheap and lightweight way of deploying a full blockchain stack. So you, whenever you have to agree and share information between different parties and you want to have fast consensus with fast finality, it may be a good option to deploy an IPC subnet. If you are used to interacting with FVM smart contracts, but the Filecoin mainnet may not have the high throughput and faster finality that you need, but you still want to be able to interact with storage that lives in the Filecoin mainnet, this may be a good case. As I said, like it is an easy way of deploying a full-fledged blockchain. You have some features to interact with other blockchain, like other subnets in the hierarchy, but you don't need to use it. You just spawn your Lotus with some with this fast consensus, invite a bunch of validators, and you will be able to run this blockchain with all of the RPCs and the semantics that you're used to from the Filecoin ecosystem and the Filecoin stack. And of course, like if you have an application that needs an incentive mechanism, but you don't want to figure out like all of the blockchain, all of the crypto token and so on, it may be a good option, and also for verifiable computation. Right now, we have like the amount of features that we have, of course, it's limited, but we're growing in the number of features, and like we want to be able to switch runtimes, to configure the cache costs. So in the future, you will be able to do more stuff and configure and fine-tune the substrate of these subnets to fit better the needs of your applications. And moving to more practical matters, if you want to start like tinkering with IPC, here I share a few, and I can share at the end the slides so that you have you can navigate all of these links. But we have already a testnet where you can interact with IPC, and that runs the IPC protocol. This is called, this subnet is called SpaceNet, and if you go to FOSS's SpaceNet IPC space, you will be able to get some test Filecoin for the SpaceNet network. all of the instructions of how to connect to SpaceNet and how to use SpaceNet can be found in this repo. And then if you want to learn more about IPC, what is the mirror transfer protocol, what is mirror, how IPC works, and so on, I highly recommend going into this ipc.space link, where hopefully you will have references to all of the basic knowledge that you need and the basic reference to start using IPC. Then for the technical implementation, all of IPC runs on 4 different code bases. So actually 3 different code bases, but one is replicated because we initially, like, subnets right now run through a set of FVM contracts that are native actors. So they're bundled with the built-in actors. This has historical reasons, but yeah, like the reference implementation is written in Rust and it's bundled in the built-in actors when you deploy a subnet. But we're working on a set of IPC on an implementation of the IPC contracts for Solidity, so that they can be deployed in calibration net, in even the Filecoin mainnet, and so in that way we are able to deploy subnets from these networks. And finally, the other 2, so that's why I said that there are 3 main code bases. This could be one, like the on-chain logic implemented through a Solidity contracts and a set of native actors. And then we have Eudico, which is our fork of Lotus with the modified consensus and other IPC related features, and the IPC agent, which is the central point and this abstraction that you can run in order to orchestrate all of the low-level interactions with the different subnets and what your application will potentially use to interact with IPC. Finally, like before I move into the demo, there's so if you want to know more about Consensus Lab and what we're doing, so IPC is one of the projects that we're doing, but we're also like figuring out ways of scaling Filecoin through the consensus algorithm and so on. I leave you here a bunch of links if you want to learn more about what our team does. And finally, like if you have questions, if you have like even suggestions, bug fixes, like whatever you wanna, if you want to interact with the team, these are we live in Slack and in the Filecoin Slack, and these are some of the interesting channels where you can interact with us. The consensus for more of general consensus algorithm related or scalability related topics, the IPC specific channels, and finally the SpaceNet specific channel for those of you that are interacting with SpaceNet and you have questions, bugs, suggestions, any other thing that may come up. And yeah, and like what I would recommend, there's a lot of information here and it may be hard to grasp initially, but my recommendation would be to initially just go to the ipc.space website that I mentioned, and then reading a bit this IPC agent, the IPC agent documentation in the IPC agent repo that I just shared, and the SpaceNet, like skimming through the SpaceNet repo, and it would give you a sense of what is the state of the technology and how you can start interacting using IPC and building application on top of the SpaceNet and IPC testnet. And finally, let's start with the demo. So what I'm going to do for this demo, I already deployed a subnet. I'm going to show you briefly how to deploy a subnet, but whatever works. So I'm going to show you how to deploy a contract in a subnet. And it's not as exciting as it sounds, because in the end, the fact that we're using Lotus means that everything that you see in the Filecoin docs, and that's why I link it here, regarding smart contracts, not storage specific features, but all of the like smart contracts, interaction with FEVM, all of the CLI commands and RPC endpoints that we have learned to love, all of them are exposed for subnets because we are a fork of Lotus. So in the end, anything that you want to do in a subnet ideally should work from scratch. So you just have to follow the Filecoin docs, just that the blockchain stack that you're interacting with is different. I mentioned this because if you see that there's something that is not supported, or you follow the Filecoin docs and something fails, come to the Filecoin Slack, start ranting about it so that we are aware that this is the case. And with this, I'm going to start sharing briefly my terminal to show you something, and then I'm going to come back to my browser. All right, so I guess that, I hope everyone can see now my terminal. right now what I'm showing is just to show you what is a subnet running. So in the top screen, you can see my IPC agent connected to the different subnets that I'm running. And then in the bottom screen, you see one of my subnets running. I'm just showing you how it's generating blocks every second because we're running this Trust consensus. So I'm going to show you briefly like the IPC agent CLI to show you some of the commands that we support. So you see that you can run the daemon. There's a bunch of subnet-specific operations, config operations, wallet, cross messages, checkpoints. So there are a bunch of operations there that allow you to interact with and use IPC through the subnets. And the most interesting ones, of course, are the IPC agent subnet that gives us like all of the things that we can do related to subnets. Right now, you can see here in subnet list that I'm running just one subnet, that is this root T01002, that it's running with a collateral of 2 Filecoin, and that it has this 192 circulating supply inside. So this is the amount of Filecoin that has gone from the rootnet, so from SpaceNet to from the SpaceNet rootnet to the subnet, so that it can be used there. If we want to deploy a subnet, it's quite straightforward. So the steps are the following. First, we deploy our subnet actor that is going to govern the policies for our subnet, that this lives in the pan. So if let's do this subnet create. So I'm saying I'm going to create a subnet with from the root, I put some random name, and I say the minimum number of validators, the checkpoint period, and so on. Like potentially, once you read the documentation, all of these, because we don't have a lot of time, all of these flags will make sense. But what we do with this is that we deploy a subnet actor that is going to be the one that governs the policy of our subnet. So we see that here we created subnet actor with ID T01003. If we list the subnets now, we see that the new subnet is not there yet because no one has joined. And now we're going to join the subnet so that we register and we can start. Oh, sorry, I'm joining I'm joining the wrong one. So I was joining this one. I want to join the 3 with, let's put 3 of password so that you see a different number. And then again, like the flags will make sense once you read the documentation. And you see that with this, we were able to deploy a new subnet and with 3 fibers of collateral and no circulating supply because there hasn't been any kind of interaction with that subnet yet. And from here, you will be able to deploy like your validator, deploy your subnet, and start running this independent network that I was mentioning. With this, like this is just to give you a brief overview of the end-to-end of operating a subnet. And now I'm going to move into the running a subnet, like being a user of a subnet side of things. And for this, I'm going to do this subnet RPC. To interact, to make easy the fetching all of the data to interact with a subnet, we have this command line that gives us if we are running, like now I'm running the IPC agent is interacting locally with the nodes that are running the subnet, but you could be running the subnet in some remote endpoint. And with this command, where we're getting all of the information that we need in order to connect to this subnet, because the subnet ID, the chain ID will change according to the subnet ID, and then like we may be interacting with the subnet either through Glyph or through other endpoints that is not necessarily our local peer. In our case, it's the local peer, but that way we don't have to even remember how to connect and how to interact with the subnet. So this is the endpoint of the peer running the subnet and the 10 ID. And now what I'm going to do is configure my MetaMask and deploy an FVM smart contract over this subnet to show you that the interaction is exactly the same, but it goes way faster due to the consensus algorithm that we have. So I'm going to change again what I'm sharing. here. So I'm just copying. Here I'm just connected to my IPC rootnet, and what we're gonna do is add in MetaMask the network, the new network the subnet that we want to interact with. This is the chain ID. Hopefully I know it by heart. If not, I will have to look at the. I will have to look to the terminal. So sorry about that again. You'll see it slightly. Yeah, we copy here our IPC address. The symbol is T file. All of the instructions, again, I'm doing those instructions that you can find in the Filecoin docs to show you how you can interact with the subnet using the same kind of tools that you are already using to interact with any of the testnets that run FVM or Filecoin mainnet. So now we switch to root T01002. In this case, you see that I already have some Filecoin there because I was doing some testing, but we could, I'm gonna send a bit. Yeah, actually, you don't see my terminal, so that makes no sense. And we have 3 minutes to, almost in the top of the hour. So I'm just gonna show you how to deploy a subnet. You see that MetaMask is integrated directly to the child subnet, and we are able to deploy a contract with Remix or any of the tools you're used to. And you'll see that this is gonna be really fast because the fact that we have 1 second block times makes it really fast to interact with these child subnets. So we're gonna compile this simple storage solidity contract, and let's get the injected provider. And now if we deploy, I mean, you don't see the prompt from MetaMask asking to pay for the transaction and saying the transaction, but you'll see that it should appear here almost immediately, the deployment of the contract. So I hope this has been useful. I don't know if there are questions. Sorry, I would have loved to get a full hour to explain you all of the nitty-gritty details of IPC, but happy to answer any questions or help you with anything. Thank you very much.
Yeah, if you have any questions, please feel free to type them in the chat or take yourself off mute and ask Alfonso. Currently, there are no questions in the chat, but. And yeah, if there are none, then please don't hesitate to reach out via Discord or the partner channels or any other method, and check out the partner prices and the partner pages on the Hiker dashboard as well. But yeah, if there are no questions, Meek asked, what is this useful for again?
So if you face some kind of congestion or limitation in this case Filecoin, but eventually other blockchains where, for instance, you have 30-second block times and it goes too slow, it is a good way of deploying a new instance of a subnet and getting the kind of throughput that you need for your application. So it's a way of scaling, it's a proposal to scale horizontally blockchain blockchain networks.
Cheers, thank you. And yeah, if there are no other questions, thank you, Alfonso, for the presentation today. And thank you, all the participants, for attending. And we have a few more workshops later today. And yeah, if you have any questions, please don't hesitate to reach out to the partners on the Discord channels. So thank you, everybody. Have a good rest of the day.
Thank you. Cheers.